Oh, all right. I think we're going here. I think we're live. I'm not sure. I can't really tell. Okay, let's do it. Anyway, let's talk about what we're doing today. So our goals for today are classifying polygons, finding the perimeter area of polygons. Now, we're going to talk in depth about polygons in our second semester when we get to quadrilaterals, but it's important to have this little introduction at least to what we're doing. So again, we're classifying polygons, and then we're going to be finding perimeter and area of polygons. Okay, now this is a long slide. Now we don't expect you to write down every little thing. Okay, like from you don't necessarily need to know that this is from the Greek word poly, all right, with many and gon is meaning angle. And that's not we're not going to assess you on that. We're not going to tell you, hey, where does the word polygon come from? All right, but it's important to just just to see it, all right, just to talk about it briefly. Some things I would write down. So what is a polygon? Closed figure, 3 or more sides. Okay, maybe that's something you could write down. Okay, sides intersect at points and called vertices. Now, obviously, use this shorthand. Maybe for points, you write PTS for points. Okay, the angle between, I write BTWN. That is a W, yes. Two sides is called an interior angle or a vertex angle. Okay, that is important. We're going to talk a lot about that at some point, and we're going to continue to talk about that. All right, so understanding that we have interior and vertex angles, those are important. Okay, you name a polygon by listing its vertices consecutively. So what I mean by that is if I have this polygon here, all right, if I have A, B, C, D, I would say that's polygon A, B, C, D. I cannot say that's polygon ACDB. That wouldn't make any sense. Okay, it has to go around in a circle one way or the other. All right. There's two different types of polygons. Okay? We're not. I'm not. These are examples of those two. Right? These are not polygons. Why? Because this has a curved side. We can only have straight. A circle is not technically a polygon. It's just a circle. Okay. This is not a polygon because it's not a closed figure. These two individually are polygons or triangles, but this as a whole is not. All right. It may not be. That is okay. Anyway, so there's a difference. Okay, there's two different types. There's convex and concave polygons. Convex is this long, which interior angle has a measure of less than 180. That should be 180, not 0, but 180 degrees. Concave polygon is a polygon where at least one of the angles is greater than 180. Notice this black segment is drawn. That's a straight angle, just for you to recognize that this is greater than 180. Okay, now here's the other deal. All right, here's the deal with these. Okay, I just lost my train of thought. Oh, okay. What was I going to say? Concave. It looks like they cave in. Like I can make a Pac-Man. Like I can draw a face in here. Here's the teeth. Here's the nose. Here's the eyes. Like you can make a little Pac-Man. Okay. When I think of concave, I think Pac-Man for some reason. All right, but like obviously it's a block Pac-Man, like something like this. All right, there's our Pac-Man. Okay, obviously I know that Pac-Man really looks like this, but that would not be a polygon. Okay, that would not be a polygon. All right, so there are different names for polygons. Okay, so now I don't know. I mean, it's important to know these names. We're gonna continue to refer to these names. All right, maybe if you want to pause it and write these down, that's fair. You want to take a picture, that's cool too. Anything that's not listed here with a number of sides, so like 11 sides. 11 sides would be an 11 gon. Sometimes mathematicians are lazy. We just do it like that. Like 100 is not listed here. I would call that a 100 gon. Okay, that's pretty neat. I'm going pretty fast, but again, biggest takeaway for right now: concave means it caves in. Convex does not. Understand the names of polygons, 3 sides of the triangle, and so on and so forth. 7 is a heptagon. That's what we call it, not a heptagon. 9 is a nonagon, decagon, dodecagon, pentadecagon. Classify either as concave or convex. Go ahead and pause the video and try to do that. And by number of sides, sorry. All right, hopefully you pause it. This should be a convex polygon. It has 1, 2, 3, 4, 5 sides, so it is a pentagon. All right, this should be a concave. It has 1, 2, 3, holy buckets, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is a dodecagon. All right. Here we go. So now we're going to change gears a little bit. All right. Hopefully you understand the difference between concave and convex. We're going to change gears and talk about perimeter versus area. Now, you know, in movies, a lot of times you see things like you hear people say like secure the perimeter, right? Secure the perimeter. What are they doing? Well, they're thinking about a building and they're going all the way around that building to secure that perimeter. Well, perimeter, I need to do, I just need to add up all the sides. Side lengths. Why? What is the perimeter? It's the distance around. That's an E right here. The other one's a C. Around. Okay. Now let's talk about area. Now you've probably found area of rectangles before and found area of squares before as well. You know, you've heard a lot of different names for areas of rectangles, like length times width, base times height. Okay. I'm going to use base times height just to stay consistent and write base times height, where B equals the base and H equals the height. And there's a reason I use base times height for now instead of length times width. Okay. Really, what's a square? Well, how do you find the area of a square? It's technically base times height, but I'm going to use S equals side because in a square, we know that all the sides are the same. So really, I can just do the side squared. I can just square a side because realistically, if this is 4 and 4, well, I'm doing 4 times 4, which is just 4 squared. I'm going pretty quick here. I recognize that. Let me see if I can pause. I think I'm back. Anyway, so now I want to talk about a triangle. Well, if the whole thing to find the area of this rectangle is base times height, what is the triangle in relation to that? Well, the triangle is only half of that. So to find the area of the triangle, I do base times height divided by 2. Or some people think of it, it's easier sometimes for some people to say 1/2 base times height. I am going to do, we'll be using this, base times height divided by 2. I think that's easier. It's up to you. Triangles can be, you know, can look a lot, can be very different. There's a lot of different types of triangles out there. You know, there's acute triangles. There are obtuse triangles. We're going to talk more about this later in the semester. There are equilateral. There's right. There's all these other ones. Okay. So the heights of the triangle must form a right angle with the base. So in this first triangle here, okay, my height is going to be interior. This is an example of an interior height. Why? Because on the inside of the triangle. Now, technically, I could also have a height that went from here. So if you can maybe see a problem that looks like this, where the height goes through the shape like that. As long as it makes a right angle with the base, that's fine, okay? Just because it looks different, it's not vertical, that doesn't matter, all right? It can still be considered a height. Can triangles have multiple heights? You know, Technically, yes, but I mean, I would say that they're probably going to be the same, right? Now, this is just a triangle where this is the height and this is the base. There's no special name for this type of height. It's just a side. Here, this is going to be an example of an exterior height. Okay, and how does that look? Well, the exterior height would be extended from one of the sides and look like that, where this is the height. And just this part right here, just this side would be considered the base. This little piece that's in green doesn't really concern me when I'm finding the area. The only thing that concerns me is this purple side, the base, and the height right here on the exterior. All right, so given the rectangle ABCD with the following points, okay, A is -3, 2. B is -3, -3. C is 2, -3. And D is 2, 2. So I have A, B, C, and D. First question, part A asks to find the perimeter. Now, again, the perimeter is just the distance around a shape, so I need to add up all the sides. Or I need to find the length of each side. Well, if I count, let's count it. I go 1, 2, 3, 4, 5 units. 1, 2, 3, 4, 5 units. I'm guessing this is going to be 5 and this is going to be 5. So technically, this is what type of shape? It's a square, all right? But technically, a square is a rectangle, okay? Yeah, so our perimeter is going to be 20 units. Part B asks for the area. Area equals base times height. So the area equals 5 times 5, which is 25 units squared. Area is always measured in square units. I think of area, here is the area on the inside. I think of area as like the amount of tomato sauce I want to use to cover a pizza. And now obviously I realize that, there's a part of the crust that doesn't always get covered, but there is, that's how I think of it. I think of the crust as being the sides right here, and the area is just the sauce that goes in between those sides. Okay. Lastly, find the area of the triangle. All right, find the area of triangle ABC. Well, I have A, B, C. So here's my triangle right there. ABC. Luckily, I know this is a right angle. So that means my base and my height are both 5. So the area is going to be 5 times 5 over 2. 5 times 5 is 25. 25 divided by 2 is 12.5 units squared. Hopefully that wasn't too bad of an introduction to perimeter and area. That's it for the video today. Adios.